Well, thanks so much, Randy, and I'm so happy to be here. And I want to tell you how happy I am. I'm happy because I got out of the board meeting to come here and give this talk. So anyway, no, the ICEP board is holding one of their semi-annual meetings today, talking about a lot of great new initiatives. And I was very happy to be there, but I'm also happy to be here in front of you to talk about the future of EV research. So how do I get to talk about this, right? I mean, I'm not a very young guy anymore, at least, and I don't know a whole lot about the future, but I'm going to try. And what I would like to do is basically take us on a little journey, maybe a little bit around Australia, but mostly from pessimism to optimism. So we heard about some of the things that EVs don't do, and I'm going to talk about some of those too. But these things that we recognize about EVs that they cannot do also give us the opportunity to do something new. And I think there's a lot more to learn about the field and a lot of things that people in this room are going to be discovering in the next few years. So let's see here. I'm not advancing for some reason. Yeah? No? There we go. So I'm going to start out with something a little bit personal. We start with my little EV over here. We're going to go along to the science. What is it that I want to do with my EVs? And yeah, this is not, is there some way that I can do this manually? I'm clicking. I really am clicking. All right. Well, I want to talk about the science again. So maybe some of the things that we have learned recently that we can't do so easily. And then we're going to go to the wider scale. So what can we all do together? How can we work together to forge this future of EVs? We can't predict where it's going to go, but we can at least work on it. So imposter syndrome. How many people here have sometimes felt like they're an imposter? I mean, I felt like a total imposter when I took that quiz and I realized that I'm just barely ranking in the top 50% of everybody. What? I picked well, of course I picked the kangaroo. That's what I study. But you know, imposter syndrome it affects us all. And so sometimes, you know, we want to think of ourselves as this EV that's packed with a lot of cargo and doing a lot of things, but when we look at the mirror on the wall, this is what we see. And I mean, when I was standing up here on the stage with Randy, you know, one of the guys on the stage was on the flight, like drinking a bunch of wine, and the other one was programming a blood EV simulation in Python. So that tells you a lot about who's the real imposter here, right? But I think that we have to learn from this. So we tend to look at ourselves and see our limitations very easily. But the fact that we're sitting in here and learning from each other means that we can do a lot together and that we should not feel like imposters. So as we advocate for EVs, we also have to advocate for ourselves. So sometimes we go kind of to the opposite with how we look at the stuff that we're studying. So we think, well, I'm a pretty simple person. I'm not going to be able to do this. The stuff that I'm studying is really complex and really, very important. I don't know if I can do this. Here is Uluru. So how many people here have been to Uluru? And see, this is an amazing place. If you have some time here in Australia, go out into the middle of the beautiful continent and see this place. So we're on this journey, and we basically want to be able to move from what I want the EV to do, what I think the EV does, to what it actually is doing. And important, you know, as we try to do this, we have to recognize some of these limitations. So I'm going to just stay with the pessimism for a few seconds here. Going to a paper back from 2020, so a lot of us are working on biomarkers of EVs. We heard from Randy about how little content some of the EVs actually have. So if you go through some of the calculations here, you can get a little depressed. You know, you learn that the stoichiometry of the EVs in blood, you know, some people have measured how many EVs are actually coming from any organ other than the blood. And that might be 0.2%. And then if you think about a particular tissue, maybe it's the spleen, maybe it's the brain, whatever. You can come up with some calculations here. And if we then go back to Rink's and Randy's numbers of the number of EVs in blood by unit volume, we can do these calculations and we can say, well, maybe there's a few thousand EVs in a particular ml of blood. And then we go to that table from from the paper about 10 years ago, which may have even overestimated how many microRNAs of a particular type are in an EV. And we come up with this like 1.3 copies of that microRNA that might be in a given ml of blood, and that's with 100% recovery of the EVs. So there are definitely some things that we cannot do. This also goes to the therapeutic side. So many of you have read this paper. We featured this as a preprint on the EV Club. It was one of the most watched EV clubs, and I really miss EV Club. I hope I can do that again sometime. But this paper, what they did was they looked at EVs that were made from an engineered cell line or from a native cell line. The engineering part was to add VSVG. So this is this viral glycoprotein that helps virus particles to get into cells. And without the virus particle, don't look at the numbers here, just look at the colors. Without the viral protein, you pretty much got no delivery of this cargo into the cells. And yet, when we look at the literature over the last 10, 12 years, this is the kind of paper, there's thousands of papers like this in the literature. I'm not knocking the people who've done this. I've published some of these papers where we say, here's a microRNA, it regulates 1, 2, 3, 4 things in this condition, and we go through this very cookie cutter kind of approach to science, and then we find out, wait a second, how is all of this working? So I stole this title from Randy. I'm not sure if he actually used this in his talk, but does anybody know who this person is I'm depicting here? This is T.S. Eliot, so a very famous poet from the early part of last century. And he wrote a poem in which there was a very famous line, and it was, "This is the way the world ends, not with a bang, but with a whimper." And I thought of this as I was thinking about EVs because we also have to think about how the EV ends. An EV is traveling around the body, it gets to its target cell, and then bang, what happens? Does it actually transfer all this cargo and completely change the cell like the one on the left where you have this, now it's all green? Or is it more like the whimper on the right, where there's just a tiny little bit of cargo that may or may not have been transferred into the actual cytoplasm? Maybe it's doing something, maybe it's not. What is the reality here? And what are we actually trying to achieve with these EVs? So let's go back to the numbers. We heard about the surface versus the interior. This is a paper, I don't know if Oscar is here, Oscar Stauffer or Kevin Janka, I don't know if they're here in the audience, but they wrote this nice paper in JEV recently, just came out at the end of last month. If you haven't read it, I would take a look at this because they very nicely formulated something that many of us have been discussing for years, but that few of us are actually doing much research on. And actually, Oscar had a very nice primary research paper recently where he showed some of these concepts are probably pretty accurate. So when we consider the volume of the EV versus its surface area, it's actually the surface area that might be able to achieve some signaling, and this opens up a whole new horizon for us, right? So when we talk about the short distance signaling, the long distance signaling, and then whether something is contact dependent or contact independent. This is what these authors propose, namely that an EV can function by contacting a cell through the surface. So basically it's kind of like a virus. So I'm a virologist by training, and so a virus can bind to specific receptors. Sometimes you have multiple proteins that are coordinating together, and because of this membrane fluidity, you can actually get complexes that are formed that are able to do things that they wouldn't do when there's just one or two proteins there on their own. So this paper is called Membranes on the Move. I really like this. And it tells me that there is so much cool stuff that we can do with EVs that we weren't thinking about because here's Magnetic Island. So the little red dot there is Magnetic Island. I visited Magnetic Island recently. I had the privilege to do this, and I was riding around on this electric bike. And if any of you are squeamish, please look away for a second. This is what I saw everywhere. So this is a cane toad that has been flattened on the road. And the cane toad, this is a destructive process. When the cane toad gets run over, that's the end. And in the same way, when an EV bumps into a cell and releases its content, it's dead. That's the end of it, right? You got to throw a lot of EVs at a cell to do something. But here's the beautiful cane toad in a non-destructive fashion. And it's coming out to get us, and it can get you, and it can get me, and it can scare us all when it shows up in your bathtub. So the EV, I think that we have ways that we can think about EVs where an EV could actually pop around from one cell to another and do all sorts of stuff without getting destroyed. So this is very exciting for me. And so we keep the dream alive. You know, we find some things that aren't going to work with EVs. We find out other things that are going to work maybe very, very well. And this is important because there's plenty of pessimism in the world. So as most of you know, Kodiak fell apart last year. This is very disappointing. I mean, they did some really amazing work. I learned a lot from some of the scientists at Kodiak. We still use things that they developed in our own work. But you know, people, investors, reviewers, they say, oh, isn't the exosome field dead because Kodiak fell apart? No, it's not. We have many companies that are out there that are working on EVs. We have many of you are starting new companies, and you will start new companies. And so we have collectively the ability to advance this field into the future. And to do this, and here's a bridge, famous bridge in Sydney, we need to build bridges. So we can't just stay within ourselves. We have to reach out, and we have to make sure that all of the stakeholders in the community are involved. And this includes academics, it includes industry, it includes regulatory folks. And I think it's very important to recognize that over the years, ICEF has kind of developed from a society that was founded as an academic scientist kind of society to a society where there's a lot more diversity actually in backgrounds and in opportunities. You're seeing over here on the right, this is actually a slide that Konstantin Konstantinov, who is at Kodiak, had asked me to make several years ago. He said, how many industry participants are actually coming to these meetings, these annual meetings? And it turns out that there was this almost perfect increase from year to year. And I'm sure that is continuing as we speak. So ICEV, we as a community, we are including all stakeholders, and we need to work together to achieve growth. One of the manifestations of this desire of us as a society is a new committee that has been formed on the ICEV board, or with the ICEV board. And so Juan Manuel Falcon is going to be leading this, if you all confirm him at the General Assembly on Saturday. So please come to the General Assembly. And by the way, General Assembly, there's actually a restaurant that's right by the river called the General Assembly. When we ask you to come to the General Assembly on Saturday, come here, not to the restaurant, okay? But this is a way, this translation, regulation, and advocacy committee is going to be a way to bring all of the stakeholders together so that we can achieve the future of EVs collaboratively. And part of this is also some new special interest groups that have formed under Metka Lanasi as our outgoing chair of science and meetings, including one on the nervous systems, one on the genitourinary systems, and their EVs. So along the way, of course, we try to talk about transparency, we try to talk about rigor, how we can advance rigor. And there are all of these things. You probably read some of these papers on different sources of EVs. Of course, we had MISEV that came out recently. But you know, let's not talk about what we should not do. Let's make sure that we're not going to be I can't say this word still, but beware of the dogma. Beware of forcing people to do things, making our research into a cookie cutter. Just back off. Does anybody know what this thing is? This is the Tasmanian devil, the famous Tasmanian devil. And I love the Tasmanian devil for many reasons. One of them being that as a virologist, it's pretty cool for me that these things have a virus that transmits cancer. So it's a very, very interesting story. But we as a field, we don't want to shut down people. We want to enable research. And on that island where the Tasmanian devil lives, here's a ruins of a prison. So let's make sure that we break down the prisons. And as we're doing all of our advocacy and our regulation and so on, let's make sure that we don't establish new dogmas, but we rather open up the field and pursue new ideas. So part of this, of course, is education days like today and educational initiatives that we're going to be hearing a lot more about. ICEV has a YouTube channel where we have a lot of educational videos, things from the EV Club, but the massive online open courses and some other offerings, and then SNEV. So you all know about SNEV. If you're not part of SNEV, please join it. We are actually going to be joining together more formally, ICEV and SNEV. So there are going to be many opportunities in the future for education, hopefully under Randy Carney as our new chair of education, and that will include some new membership, some new mentorship initiatives. So thank you all. I hope that I've instilled some optimism about the future, even if I don't know exactly where it's going to go. And well, we'll have some beers or other beverages of choice in the near future. So I will now hand it back to our chairs.